Again, we delivered these projects together. So this involved over 2,000 enterprises of different scopes. So many people who were involved in this project. So the number of these people was quite important. So these are the projects which I had. So they are listed in the slide, and I will refer to each of the projects. So again, we had a number of challenges that we needed to solve. So we solved different problems. We had this Cosmos 3M rocket at the top of that. So there's two-stage rocket at its head. We had this minor 4-meter high apparatus rocket plane. Okay, so this is what we have. It reaches the orbit, and then there is this top part, which is then released, and then it starts its self-sufficient flight beyond the orbit, beyond the perimeter of the orbit. So this is 204 kilometers apogeos and perigeos at 158 kilometers. So its task is to then work and then land on water. Speaking of Kazakhstan, so we've seen different so we have this water and all that. So again, there was this needed geographic scope, Soviet Union and all that, etc. So again, we had this conflicts related to space when I had this training as an engineer in the space industry. I asked this question, and then when we had this question with the 6 laps circles made around the Earth, and ours could only make 5, and again we saw that that was the narcotic impact on astronauts. So they tried doing that and they weren't a success. So because of that, so this is a number of circles done. So again, this was the trajectory of this movement, of the movement of a spaceship. For it to make 6 circles or 12 circles, this was the basis for these calculations. So again, we had to land it because of that. So like she said, Yuri Gagarin was not the real astronaut. That was German Titov, who could make these circles around Earth when he reached the space and he needed to make 6 circles, not 1 circle. So the body itself, a human body, responds to these changes very badly. So, and again, she used this analogy, this equivalent, when there is a young person or having too much, drunk too much, that was his body, meaning, and trying to avoid release this from the body to avoid this toxic impact, toxic effect because of that. So we have this as a result, as an outcome. So this was the impact on a human's body with Earth's gravitation when there is this inner infrastructure built in such a way that we can walk, not fly somewhere in space. So this was the situation with Mr. Titov. He lost consciousness, and we thought that he would die. But then after that, he managed to adapt to the situation, like Titov used to tell us when he moved his hand. He thought that if I can use my conscience to use my hands, then I'm good. I'm okay, and my health has not been undermined. So we've heard many very interesting stories about this situation. So we needed to launch this small spaceship and to send it to space. It was able to make 1.5 circles around the Earth. We sent 2 ships like that. These were 2 spaceships. We sent them to the Indian Ocean, to the neutral area. And this was a top secret related to that. So this major project required top secret to be complied with. So this spaceship is a small one with 4 meters long, and its distance between the wings is almost 2 meters, and then its dimension, its height is almost 120 centimeters. Now this is the structure, so this spaceship should have been able to fly in the space itself, and we just wanted to check its components that were available for this one to be able to work on that. So when we return this spaceship, and when it returns back to Earth, it reaches through dense layers of the atmosphere, and for that we need to organize this thermal insulation on its surface to stand below it. And we also put those insulations over the rear front console, and we also needed to provide this nuclear defense, nuclear protection. We also wanted to have it operated automatically to be able to fly in space and then land it. So this was the achievement. In 1978, there was Buran flight, which broke the Guinness record when the first spaceship reached of the space area and then came back without any damages. There is one specific feature due to the fact that this vehicle, space vehicle BOR 4, so when it had its engines, so there was maneuvering, so he needed these engines to be able to keep this trajectory based on those meters to avoid this energy spent for those batteries inside. So before its connection, this energy was delivered from the rocket itself to ensure that we have this two caps which are connected in this area. So we see that this is the connection, which is done in this way, which provides power until it is disconnected, disjoint. So again, there is this second stage, and these thermal insulated caps, they are latched, and all that is a proved connection. So again, there is this Bohr copy Bohr unit, which did real flights. There is this back wall. We have these two caps there. To the left, we have two sockets. To the right, we have two more sockets. But there is this specific feature for these sockets. First of all, they have different forces of joining and disjoining. Here we have 52 kilos, and there we have 75 kilos. So again, 52 kilos, 75 kilos. So again, those golden end joints need to be connected properly, so manually it cannot be done. So that's why I decided to solve this problem, to perform this tight connection. I invented this dedicated equipment to ensure this connection. So this equipment has different dimensions. Again, these elements inside it for the bore itself. So those elements were inside, and they were asymmetrical. So again, I have done this for the connection. So and again, there was no power supply. We needed this power supply while the rocket was flying with the launcher. When it needed to switch to a full-fledged flight, it was connected with cables, so those cables were quite tight, and we wanted to whether remove these elements or do anything else. So if we remove them, there will be tails going out, and this will impact the dynamics of the flight. So again, we wanted after that to possibly keep it inside, but that was not acceptable either. So we really needed to solve this problem on how to disconnect it. So then I had this next task on disconnection, because I was the one to come up with the idea for connection. So I decided to create this automatic system. So they wanted to set up it automatically, which should be a simple one to be able to address this in a proper manner. So we created this uh, plates, circuits performing two functions. The first function was that we could connect those sockets together, and then those circuits, so we could use them with a dedicated spring. We have those dedicated springs for each of the sockets so that they would work together to be able to provide this disconnection when first bolts are going to be removed. Then after that we have this military acceptance after that, so they were like, you did a great job as industrial specialists. What are the guarantees? Where are the guarantees that there will be displacement? There would be a displacement after the first bolts trigger, then the vehicle is then disjointed from the frame holding the launcher. So again, what about the springs there? So possibly those springs are manufactured in such a way that there will be a displacement, there will be a movement, or there can be some other changes to the structure. So again, they wanted somehow to address this issue, and they spoke of those possible risks. So they again needed us to define it, and for that we needed a context of loss of this space-like conditions, which is feveriness or gravity absence. This is what we needed, and this could cost millions. So and again, so we decided to address this issue to avoid this displacement of the orientation of the vehicle, the flying vehicle. So again, if we had those deviations within the allowed tolerances, again, so we decided to create those additional elements that could tailor those displacements. So those who were in charge of the trajectory of the flight, they were against it because they were like, there is fuel inside the vehicle. We are not aware of any changes during the flight. Besides that, it will be also able to enter the space near the Earth. So if there will be no fuel during this disconnection, then it will be very hard to do it, and there are no guarantees which can be provided. So they wanted us to avoid having tests in space, so we needed to test it on the surface of the Earth with in gravity-free conditions. So we decided to solve this problem. So the next part is how we address this problem, how we solve this problem. Again, the problem itself and the vehicle itself is almost 1.5 tons, has a mass of 1.5 tons. So again, almost 10% of its mass is this area. So this means that the risks can be very high in case of any tangage or displacement. So we really need to create such a model that could simulate this finished product. So we wanted to create this model of a vehicle with all its characteristics in terms of mass. For that, we needed to define its weight. So we needed to understand the weight before we start, before the launch, which is 1.5 tons. And then after that, during the flight, we had this 1,700 kilos, which is lost after that when it's landed on water. So we decided then to understand its center of gravity. So the center of gravity will be the place which will feel the impact of all these changes. There are no data like that, so my wife was responsible for this secret work, working in the secret team. She was responsible for in charge of calculating those centers of gravity, those central axis centers of gravity centers to be able to avoid and ensure proper aerodynamics again, understanding the sport of the vehicle, of a flying vehicle. So she wanted to find this spot by means of calculation. So I did receive this data on the center of gravity for the free axis of the free coordinates. So then after that, we needed to have this equal weight and scale. So we wanted to have it as smooth as possible. The problem was solved in a very simple way. So we added those rods to each of the sides. So we had this calculated center of gravity, and then we fixed the center of gravity by means of adding those rods. So we added those elements to this side, and we also wanted to perform this connection with the mass of the box to be able to calculate additional gravities, additional masses to those 1.5 tons. So this was a very interesting tie which we created, a very good model, and it was very good that I was capable of solving these problems when it comes to the results of the designer's work. This was top secret. I have a photo which is quite an exclusive one, and you will be able to see it. So this is what we had. This is the weight model of BOR 4. You see this top fragment, which is a fragment of the launcher. Now here we have this frame for which we needed to get through and insert 4 belts. And again, that was a place where we had to distribute these launching devices. And then after that, we added 5 pyro bolts, those 5 connection points to the launcher. And then after that, we see those elements which ensure orientation, proper orientation. This is the calculated gravity center. So this is what we used to perform the calculation. So we use those moving elements to be able to calculate all that. So again, these were the elements resembling those elements we have in sport gyms for heavy lifting. So, and again, we moved that in horizontal directions, and then we added those elements from other sides too. So it was very hard to calculate it. And it was even harder to do that than to do that physically. So ensuring gravity-free conditions. So how do we provide gravity-free conditions for such model to be able to imitate, to simulate this gravity-free? How can it be done? We found a very simple solution. So in this part here, in the center of gravity, we added those belts here. So this hanger there was, we had those 15 meters high. So we put everything like that there. And it was like hanging on top. It was first stationary. So we pulled that before moving it further. So we just performed this action. So before doing the experiment, it was in this gravity-free condition. So we closed the hanger to avoid any airflows inside, to avoid any impacts or any additional effects created, impacted on this model, simulated model. So, and again, after that, and there is the second picture in there. So those pyro bolts were triggered, and then after that, we added a video cam or cinematic cameras. So again, we added that. So we then launched it in the presence of the military. It was Sunday. We performed this shooting on Sunday, and then everyone was very much serious and hopeful of hoping for a good result, whether there will be displacement or not. When fireballs were triggered, actuated, so they released a model. After that, we had this result. We removed those connections and those springs that I designed. They pushed the model, and the model itself moved away without any conditions, without any undermining efforts and impacts. And after that, there was whistleblower. So this was a very interesting project I had in my experience. So before I had this photo taken, I addressed another issue, which is to overcome this contradiction. Again, though, for those photos that should be secret or they shouldn't be secret, to leave this image of what I designed. It does not always work for this kind of work because you have your drawings which are top secret, and you sometimes do not see the final result of this activity after production. When the customer takes it, you design something else while you are not working at it even further on that. So again, I try to draw these pictures to be able to represent what I was working on.
Тогда, когда выходит самостоятельный полет, если обратите внимание, с левой стороны он компактный, он не должен уже вот.
So you can see that from the left side, it's pretty compact and it doesn't spread out its consoles. So when it is in self-standing flight, especially going through some pretty dense layers, so we had to make the right layout of the wind. So you have to design the system internally, which should be located correctly. For those winds, consoles would be spread out and would be going in that very location and be established in this very position. So here is reductor. We had to make a pretty compact reductor, and finally everything was finalized. And colleagues, I would like to tell you that those pictures, those photos which you see, these all are from the web, from open source. It's not drawn by me. I found them, but they're somehow related to those developments which I made. And of course, I made this very picture, pretty humorous thing. So this reductor was very cute. And so you can see it's July of 1980. Also, there is another interesting thing. So this is like with double intention. First, psychological, and the second one to resolve some issues. So at first, I will show you the comparison. So you can see this bore 4 on the sizes on the you see the size is the same as at the usual automobile. So for example, very famous car was 2101 in 1980. So they're very similar on the size, on the parameters, and of course the mass, the weight of this bore. A flying object is much bigger, and especially when it is landing, so the weight is like 1500 kilos. So, and you know, this task of designers, of ideologists of this project, you see the earth is pretty large, and you have to come to the surface of the water. And so the start was the taking off was because everything was in secret, and we had to find out where to take off and then to land in Indian Ocean, you see. So then we will lose the model, and on not only telemetrical parameters are important, but the most important to land it on water, to catch it from there, to find it, and then after, in the end, it's not 1500 kilos, but 800 kilos, a pretty heavy one. So it should have been on the surface of water, but because it was in neutral waters, who would be the first to detect it, so then it will be his. So everything was in secret. Australians, Americans were very much concerned about landing and water of this thing. When they saw the waters and everything, so of this splashing down, so they were anxious because control center didn't know about that, and nobody would like to take responsibility as per weather conditions, for example, of this splashing down, splash down, and then calculations for such flying objects with such sizes, with those shapes of that current state. It was not calculated very much precisely. So Herman Titov was dealing with this thing, with this project, and he said that splashing down should be in the Black Sea. So it could be by our own efforts. But as per other seas, the risk is very harsh because you see, back then we had pretty serious political situation as it is now. So when they were looking at the forecast of weather, so those people who were at this very region, they said that the storm is coming. So it was pretty risky to take off, to launch this thing. But you see, everything was prepared, to everything was said and done, and so somebody took responsibility, and they predicted, assumed that all those weather forecasts are false ones. So for us to stop kind of that. So anyways, we pushed the button, the start happened, and this Cosmos 1374 was launched. Everything was fine. So here is the GPS coordinate of splashing down of this object. And here you can see this little like boot or iron, as they said, press iron. And so then the story has started, which is related to the question. So this object shouldn't sink. It should be on the surface of water. So it should float on water, and it should detect itself. And it is detected not only for Soviet specialists, but also for those who survey this very territory, international specialists. So how should it be done so that the floating capability would be really high? So we were looking at the resources. It was not my idea. It was resolved by the guys. So there is a special section for the parachute for braking. So it was coming through the dense layers of atmosphere, and then with the acceleration of 4 kilometers, so the lid in the upper part has been separated, and then this very braking parachute is engaged, and after parachute was functional and was engaged, after that it was not needed after in that area where it rested, so it was kicked off, and so this section was empty, and after landing, this very water of splashing down would fill up this very section, so the floating capability will be worsened. So finally, we decided as soon as this emptiness comes into this section after engaging of the braking parachute. So in that very thing, we had to put inflated elastic shell. So right away after it will be inflated, then it will create some additional volume and the density will be correct. So said and done, the concept was really good, everything's well, and because the very construction, because we had this construction design production, and our guys were doing all the phases. So, but nobody did that before. So some said we had to design it, we had to make a project for it, and who do that? So we addressed this very interesting company, Scientific Production Enterprise STAR, and it deals mainly like a target mission of that very company is the rescue means. Then they were diversified. Besides that, they were filling up with gas, and also they even were able to make a harvesting combine, but mainly they were dealing with some rescue devices, means, and I had some experience of working with this very company for rescuing our pilots, right, aircraft, fighting aircraft. In some emergency situation, their chair was put out from, like, jumped, kicked out from that shootout from the airplane, and it should be catapulted to the water, and out of the water with the special light, this pilot should be appearing. So that company was dealing all the space special suits. It's been actually designed there, all compensating costumes of the pilots. So all those chairs, special armchairs of the aircrafts, and all those emergency inflated device for landing, for, so all those letters were inflated, you see, and so that's why they had the special calculation for sealing it, for designing, and because the shell should have been elastic, we talked to them. Two of my colleagues were sent to their enterprise, to that star, and they had to design that very shell. I was not a witness of it, but the head of their department came down to me and he said, very urgently, those two guys should be sent to another topic, but your task within 3 days in your business trip to check all the drawings which they prepared in the framework of layout and preparation. But it was not like we expected. So this cone was coming out of the of that thing, you see. I didn't do that before, but you see, I had to check this very thing. So how to do it? And I recommend it to you. And for example, if they give you their drawings and they say to check it up, so first make the modeling, make some dummies of it. So I was cutting out of the paper those models, those pieces of papers, and I was trying to put it together. And if it's not really sticking together and not combining, and there are some mismatches, I told them, you know what? Only within 3 days, it's not enough to check it up. But then they said, you can stay there for some more time. And finally, I had to urgently redo it. And so we were doing geometrical things, different merges of all the borders of it. And so I had to combine it correctly, all the angles, so that it wouldn't interfering. So finally, seams were corrected. And after I finalized it, I did that cone in the scale 1 to 10. I put the lamp in the top of it, and I gave it to the head of the team, main specialist. And he said, you know what, I like your way of work. Please transfer to us. And I told them, no, you know what? No, I would stay at my position. And as the gratitude token, he was making excursion for me, and he showed me all the suits for the cosmonauts, specialized armchairs with the special shape of those astronomers. So, and we were in being hangar with a huge pool, like 10 meters long. And in the middle part, some cosmonaut was like laying there in this pool. And I said, what is that? This is like a testing bench for the hydro testing of our spacesuits. So very soon this astronomer would fly to the state, but it was in 1980. It was Vietnamese astronaut which was flying to the space. So this is the GPS coordinate of that very landing, splashing down. So here you can see the GIF picture or like little video kind of that. So this is the aircraft of Australian military forces, which was flying over that territory. And those pictures which were made, you see all those planes were there all the way, and we had to rescue urgently, swiftly, because you see, the calculation of our landing on water was like 200 kilometers plus minus error. So that's why very urgently we had to move it to the neutral zone. And after that, so here you can see those Orion airplanes, and then desertification. And our guys are very good at this, because they put special key in it, which could be opened only by our specialists. Otherwise, if they don't know how to use it and they try to open it, so after that, automatic explosion would happen, and everything what was there inside of it. So it was like a naval mine, you see, like a bomb inside. So at first you had to make it safe and against explosion, and after that, with a special stage of work, you had to put it to the final stage. So this very cone was sticking out, and of course we had to increase floatability. And also, you see on the previous slide, there was a special component with light signal. So here is the pictures of from internet. So it is made by the Australian military forces, but I changed a bit and put some colors so that it would be understandable. And so, sorry, Marat, how much time do you need? Because our interpreters work. So 5 minutes, please. So the board number 4. So special test bench so that we would check the dynamics of the thermal dynamics and others. So my front part would be placed like that, that it would be blown by the special speed, special temperature. So in this front part, there is huge amount of all sensors which were working with different. So this is my picture of what was happening. So most probably the last thing is gyroscopical
для Бора 4 гироскопы ставят, чтобы стабилизация
platforms,
происходила.
so that
Потом
the
были
internal
вызовы
stabilization
на
would be
платформ с другим
would be
управлением,
happening.
это
And then this
большие,
platform was with
рога,
another
называют,
addition
очень
and
длинные,
infillment. So
длинные,
it was bore
Советского
6.
Союза.
So because the money was finished at the
Вот
Soviet
так.
Union program, so that's why it was
Почти
finished like that.
собрал и, ну,
So I
подобным проектом
drawn
на
such a picture. And
Географическом
another
институте
project
Географии
also, when I was in that institute, I had some inventions. And
в 2009 году
in 2009, I had two inventions in Korea, personal inventions, and I got my personal award for the inventions.
это компании, в которых
So here are the companies where I worked and
где приходилось консультации проводить.
so with whom I made some consultations. So thank you
Спасибо, Марат, очень
very
интересно.
much. Yeah, it is very, very insightful and
Да,
interesting. Thank you,
Я
Marat.
думаю, там много еще есть что сказать.
Oh, I think
Да,
it's
да,
really very
задачи,
interesting, Marat. I
которые
think
как бы,
you
да,
still have a
мне
lot
как-то
to tell
решая
us.
список составлять, у меня было
Yes,
порядка
when I
40 проектов
drafted this list, I
за
had like
два
over
с половиной
40
года.
projects within this
интересно, какие из них
12.5
можно
years.
было бы
And of course,
сделать
it's very
еще
interesting
консультацию.
what kind of them could be
Ну,
represented as
думать,
Надо
training
подумать, да,
as
это
training
любопытно.
problems.
Ну,
Yes, we
А,
could think about it.
да.
коллеги, какие-то вопросы, может быть,
Now,
еще?
colleagues,
Если или уже
possibly, do we
много
have
у вас
any
мы
questions?
переработали
We really are delayed
больше
quite a bit
часа?
of 1 hour.
Спасибо, очень интересный доклад.
Thank you. That was
Спасибо
a very
большое.
interesting input.
Доктор Фабио, через 2 минуты я к вам
Dr. Faber,
перезвоню,
I will
хорошо?
come back to you
Можно
in
было бы еще
2
послушать в
minutes.
следующий раз доклады, Марат, ваши.
Marat,
А,
we would be happy to listen to
Я с
your
удовольствием, да. Ну, вот
reports
тут сейчас
at
просто
our
добавлю,
next conferences. Yes, that
19
would be
числа,
very, very
19 числа три поколения ТРИС там будет
uh,
проводиться, и меня
important.
Пчелкина
On
попросила,
the
чтобы я
19th,
выступил
Ms. Pcholkina
не по
asked me to deliver
этого проекту,
that on the
а по
19th I will be delivering
техническому.
this speech,
Вот, и
this
я там тоже подготовил
technical aspects. I'll be
один
talking
свой
about these
проект,
technical aspects on the
первое
19th,
изобретение, которое я там сделал,
about my
это
first
я
invention
назвал хвостовая
I
история
made,
первого
which
изобретения. Поэтому
this
если
is what I
кто
call the
захочет
tail story of the first
начать
invention. So
обсуждение
please,
этой идеи,
you
то
are welcome to
я с
join.
удовольствием
If not, I'll be
повторю,
happy
добавлю
to
еще к этой истории там
repeat
отдельно,
this
вот Миша там
story
говорил,
or add something to
как
it,
это
like Mikhail has mentioned,
Я говорил
if
о
there
том,
is a
что мы
meeting.
планируем сделать серию
Yes, we're
вебинаров на
planning
различные темы.
to
Вот вы эту
launch
тему подключите.
a set of
ну,
webinars
можно и так, да.
Да, мы договоримся.
in different
Хорошо,
topics, on different topics.
большое
We can
спасибо
include
за
this
внимание,
topic
спасибо,
there
что
too. Yes, we will
уделили
arrange on that.
свое
Thank you.
время.
Thank you
Спасибо,
for
Марат.
giving me the time. Thank you,
Счастливо, до
Marat.
завтра. Завтра,
Colleagues, we
ну,
see
около
you
12
tomorrow
надо
at
подключаться.
about
Zoom
12.
в 12 мы завтра
You
начнем.
need to connect to
Да,
Zoom, and we will have our second session
да,
tomorrow.
счастливо, до свидания.
Всем, да, всего
Okay.
доброго. Счастливо.
Good.